Alright, welcome back to day 5 of our investigation of gravity. Yesterday we were finding out our weight on different planets, and that helped us understand that gravity is different based on the planet that you're on. Larger planets have more gravity force, and smaller planets have less gravity force. So that got us thinking that gravity can then change, can't it, based on where you are. Today what we're going to do is to help us think more about that is we're going to do a PhET simulation called Gravity Force Lab Basics. So let's go there and see what we can learn about gravity force and how does it change. What are some other ways it can change? So when you get here, click on the play button. And now we're ready to go. So let's see, first of all, what are the different ways that we can change this simulation here. I noticed that we have two spheres. Okay, they look to be a different size here. When I look down here, the blue one has a mass of 2 billion kilograms. That's a lot, isn't it? Even though it doesn't look like a big sphere, it is very massive. Okay, and then over here, this one has twice as much. It has 4 billion kilograms. So again, huge. I don't know how these people are holding on to that. But what I want you to see here, up here at the top, we have some arrows. And these arrows are going to represent the force of gravity that's pulling on these different objects here, okay? And so over here it says force on mass 1. This is mass 1. Blue is mass 1. By mass 2, the force is 33.4 N. And that N stands for newtons, after Isaac Newton, who came up with the whole idea of what forces are. Okay, and gravity is a force. So we measure gravity in newtons. Okay, so that N stands for newtons. And over here we have, right above the red sphere, force on mass 2 by mass 1 is 33.4 newtons. First of all, notice they're the same, isn't it? Isn't that interesting? Even though this one's bigger than the blue sphere, the force of gravity on both of them are the same. Okay, so the two objects are pulling on each other the same. Let's see. If we make these, we can change their distance, we can change their mass, we can make their sizes the same. Okay, now they have the same size, I'm sorry, not the same mass there. Okay, I'm going to click off of that because I like seeing different sizes. Alright, so let's make these bigger. Oh, I'm noticing something. Every time I increase the mass, what happens to the gravity force? It was at 33 before, right? 33 newtons, now we're at 116. So I'm going to make it even bigger. I wonder how big I can make this. Oh, I can make it 10 billion kilograms. Alright, so when I do that, the forces on both of these, even the red sphere that didn't change, its force is the same as the blue. What does that tell you? Two objects that are near each other pull on each other with the same gravity force, okay? So this large one, the larger blue sphere, now it's 10 billion kilograms, more mass. What did we find out yesterday? More mass of planets, the more gravity, right? And that's what we see is happening here. I'm going to now increase the mass of the red sphere as high as I can. And check out those arrows. They are off the chart here. Now we're at 417 newtons pulling on each other, okay? Now, this next part that I'm going to talk about is going to be something I think that's new that we haven't mentioned before about gravity. Watch this. These closer together. And what happened to the gravity? Over again. We were right here. And as I get closer, what happens? Those arrows get larger and larger. We're now at over 1,000 newtons. What does that tell you about distance in gravity? The closer things are, the stronger the gravity is. So watch, what about when you pull? The farther away objects are, the less gravity they experience, less force of gravity they experience. So the farther away you go. That's why, even though Jupiter has a much stronger gravity than Earth, we don't get pulled off of Earth onto the planet Jupiter. That doesn't happen because we are so much farther away from Jupiter than we are from Earth. So we feel Earth's gravity the most, the strongest, because we are closest to Earth. Okay, so think about that. Things I want you to know from this unit. from this lesson is that the closer, the stronger the gravity is. The farther away they are, the less gravity they have. The larger the mass of the object, more gravity force. And then I'm going to show you again here, see how small I can make it. The smaller the mass, the smaller the gravity force. And look at this now, this arrow, they're far apart from each other as they can be. They're as small as they can be. And that gravity force is just barely there. It's just 1.4 newtons. 1.4 newtons is like holding 2 apples in your hand. Okay, so it's barely any force at all pulling on it. Alright. Now, once you've finished this, playing around with this, go back to the lesson for today and click on Day5 form, variables that affect gravity. And each of these questions is asking you about something in the simulator. And it's something that we just talked about. So feel free to play this again or play with the simulator again. And this will help you find out all the answers that go to this form here. And again, let me know how things are going. All right, you guys stay in touch. Have a good day. Bye-bye.